Okay, so to factor trinomials. So this is a little different than factoring by pulling out the greatest common factor, which was the last lesson. This one, it's going to focus on a method called the Australian method. So if you haven't heard of it, that's one of the ways that we're going to factor, but there's a few methods. Okay, so first I just want to go over the point of factoring, right? So if we look here, we have two binomials, and to multiply them, we do either, double distribution, or box method, or FOIL, right? They're all sort of the same thing. So you would do 2x times 3x is 6x squared, 2x times 2 is 4x, 3 times 3x is 9x, and then 3 times 2 is 6. And then that would simplify to 6x squared plus 13x plus 6. So this is multiplying, right? We did that in the multiplying polynomials unit. And then the whole point of factoring is the reverse, right? So in another lesson we said it was like undistribute. So you're pretty much going from factored form to standard, standard form to factored, right? I'm going to put this here. Factored to standard. And this is standard to factored. And the whole point is when you're in standard form versus factored form, you can get different things out of the equation. Right? Sort of like, think of like a car seat, right? Like you could have it like really close forward, you could have it really far back. It's still the same car seat, but it has different functions. Like one's for relaxing, one's for driving, right? Okay, so factoring with the Australian method. So we're going to start with our example. Let's just go back to the original, right? So we have 6x squared plus 13x plus 6. So this is the step that you have to do for all factoring, is you have to multiply to a times c and add to b. I also want to mention first, need in standard form, which is a vocab word, so you should know that it's ax squared plus bx plus c. And a, b, and c are just coefficients. Okay, so we need to multiply to a times c and add to b. So a times c is 36 and b is 13. So there's a few ways that people do it. The first way is listing out factors. So you can just start from 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, there's nothing, and then 6 and 6. So this is why it's really good to know your times table really well, because you want to be able to come up with the different factors pretty quickly. And so these are our 5 options, and then we can just add them together to see what we get. So this would be 37, 20, 15, 13, 12. And so we can see clearly this is the pair that we want, because they had to multiply to 36 and add to 13. Some people like to do this process a little bit quicker in their head, and they do this x method, and they put the 36 on top and the 13, and they just try and think in their head of the two numbers that will multiply to 36 and add to 13. So whatever works for you, listing it out, using this x method, just doing it in your head, but you're going to have to do this a lot. So it's just good to get practice in any way that you want. For me, I started off listing the factors in my head, but now I can pretty much think of them pretty quickly. Okay, so we have, we could put the 36 and 13 here. Okay, so we have 4 and 9. So the way to do the Australian method is, here, I can write the steps here. First, need in standard form. 2, find key numbers. 3, set up 2 factors with a x. or I'll be like ax all over a. Okay, so that looks weird, but pretty much you're just taking this first number here, right? So the way to set that up, so I'm going to do, this is 1, all right, this is 2. Let me do this in a different color. Just so you can like clearly see where the steps are. And then 3, we have 6x all divided by 6. Right, so that's the A, right? A, right? Just to be a little more clear, we have A equals 6, B equals 13, C equals 6. So we have AX times AX over A. 4. Put in the factors you found. That multiply to A times C and add to B, right? So 4 would be 6x, and then we had 4 and 9, so plus 4, 6x plus 9 all over 6. And then 5, simplify. So when you simplify, you should be able to remove or reduce number in denominator. If you can't do that, then something's going wrong. So for step 5, we see we can pull out greatest common factor, right? So 2, 3x plus 2, and then we can pull out a 3 here. 3x plus 3 all over 6. So this was just me pulling out greatest common factors, right? GCF. And then our final simplification is this 2 and this 3 turn into a 6, so it cancels out with this 6 on the bottom. And so we're just left with 3x plus 2, 3x plus 3. And that is, as you can see, right, that's what we had. Oh, wait, I messed this up. 6x plus 9, that should have been 2x. See, and I could check, right? I checked and I was like, okay, that wasn't the original answer, so something went wrong. And you could always double check by multiplying it out again. So this one's a little tricky because we multiplied it first, but I'm going to put that as a step 6. Check by multiplying again. Right, so if I were to multiply this out, I should get this original answer, but we already know that because that's how we started. So the Australian method, right, at first it sounds weird, but it's a lot of the same things of other methods you've learned. It's finding two numbers that multiply to A times C and add to B, and then it's just rearranging it. It's a lot more simplifying and greatest common factors. Okay, so now on the back side, I'm going to do factoring by grouping because that's something else that we've taught. And you can just decide which one you like better. I'll list off a few different methods. Okay, so we have we have 6x squared plus 13x plus 6. So same thing, right? Step 1 is in standard form. Step 2 is finding those two numbers that multiply to 36 and add to 13, which is 4 and 9. Okay, so our third step, 1 and 2, same. 3, split the x term into the numbers you found. Okay, so what does that mean? So we have, what color did I use? Green. So for 3, right, we go from this and we go 6x squared plus, instead of 13x, we're splitting it, right? So this is the x term because there's just one x. We're going to split it to the 4 and the 9. So plus 4x plus 9x plus 6. Right, so everything here is the same, except for this is split into this. But it still equals the same thing, right? This is just unsimplified. Okay. Find the greatest common factor of the first and last pair. Okay, so what does that mean, right? So I'm going to split these into 2, and I'm going to find the greatest common factor. So here the greatest common factor is 2x, and then I'm left with 3x plus 2. And then here it's 3, and I'm left with 3x plus 2. Right? So, right, this is the greatest common factor of that. 3 is the greatest common factor of that. And you need these two things to be the same for this to work. So if it's not the same, that means you're messing up. 5. Create the two factors. From the greatest common factors and the common factor. So for this one, these two on the outside, they're going to join up together and be a team. So we have 2x plus 3. And then these are already a common factor, so we're going to just set that aside. And so here we have, this is standard form to factored form. So this is factor by grouping. That's a vocab word. And this is factoring with the Australian method. I'm going to make this a 1. Okay, so I'm going to do the Australian method in green, and I'll do the factor by grouping in blue for these following problems. Okay, let's do example 3. No, let's do example 2. So we have v squared minus 14v plus 45. Alright, so our key numbers is they need to multiply to 45, and they need to add to negative 14. So if we think, right, so if it's negative, that means one of them is going to be negative. That would be if it's multiplied. So we have a negative, so we know that we're going to deal with negative numbers, but the product is positive, so they're both going to be negative. So we can think negative 5 and negative 9, but you can go through and list them if you need to. Okay, so for Australian method, we take v all over 1, and then we have negative 5 and negative 9. And that 1 is not really necessary, so we just have v minus 5, v minus 9. And then the factor by grouping, we have v squared minus 5v minus 9v plus 45. We take out the greatest common factor, v minus 5, and then we do minus 9, v minus 5. So we could take out a positive 9 and then make this negative v, but we want these to be the same. So this becomes v minus 9, v minus 5. Alright, because we took out this guy, and then here's our common factor. So if you notice, these two are the same things. They both work. Something to know when a is equal to 1 is you don't need to go through all these extra steps. You can just think of the two numbers that multiply to negative to 45 and add to negative 14, right? So with the Australian method, you can see really quickly, you can just stop right there. With factoring by grouping, you're doing all these extra steps. But right, see the negative 5 and the negative 9, those are the numbers you picked. Over here, it's a little different, right? We picked a 4 and a 9, and we ended up with like these two things. So, you know, you pick whatever method you like better. Okay. So we have example 3, 3h squared minus 2h minus 5. Our key numbers is a times c is negative 15. Add to b, add to negative 2. So we have 5 and 3, but which one is negative? The 5 is going to be negative because it needs to be a negative number. So negative 5 plus 3 is negative 2. So let's do the Australian method. So remember, we have ax, and a. So we have 3x, wait, that's an h. 3h over 3. And then we just have these numbers, so minus 5 and plus 3. And it doesn't matter the order. I could have put the 3 there. Alright, and then I'm going to pull out a greatest common factor. So this is already simplified, but this one I could pull out a greatest common factor. So I have 3h minus 5, 3h plus 1 over 3, and then those 3's cancel, so I'm just left with 3h minus 5, h plus 1. And then I'll do factor by grouping. So we go from here to 3h squared minus 5h plus 3h minus 5. We pull out our h, 3h minus 5 plus 1, 3h minus 5. We get h plus 1, 3h minus 5. Okay, one more thing that I want to note. Oh, and let's double check, right? Because, right, that's the last step is checking. So let's multiply this out. We have 3h squared minus 5h plus 3h minus 5. 3h squared minus 2h minus 5. That's the same as the original. We got it right. So that's what I mean by check. You always want to check. Another thing that you can do when you get really good at it is you can just straight up set it up. Let me see if there's any room in the notes. Not really. Okay. So I'll just speak about it. When I'm here, I can set up, right? If I have this thing right here, just make a little note here. This is going to be guess and check. This is the method that you might start to do when you get a little quicker at it, right? So if I have, let's go back to the beginning. 6x squared plus 13x plus 6. I'm going to set up the parentheses for myself, right? Set up parentheses. So it's going to be, and I know it's either going to be a 2 and a 3, or it's going to be a 1 and a 6. Because those are the only common factors. The reason why I know it's not negative is because there's no negatives there. So I know that it's not like negative 2 and negative 3 or negative 1 and negative 6. I know that they're all positive. And then I just think of the factors. So it's going to be plus 3 and plus 2 or plus 1 and plus 6. So I can just guess and check. So I'm going to be like, okay, well, if I do plus 3, that becomes a 9, plus 2, that becomes a 4, then I know that's it. So this is what I do. I set it up, and then I put in what I think it could be, and then I multiply it in my head real quick to check if it works. So this takes a lot of mental math, but if you can get it, it'll be quicker, right? If I have something different, like let's say 3h squared minus 2h minus 5, the same as example 3. Well, I know already it's going to be 3h and h probably. I don't think those are going to be negative. And then I know one of these is negative, and it adds up to 2. So I know it could be like negative 5 and 1, or 1 and negative 5. Right? And I know it needs to be more negative, so if this is negative 5h and then I add 3h, then it's negative 2. So guessing and checking is a quicker way of doing it. But if you don't like that, then stick with the Australian method or the factoring by grouping. Okay, a few more examples. We have y squared plus y minus 12. Our key numbers are they need to multiply to a, which is 1 times c, negative 12. Negative 12, they need to add to 1. Alright, and that's going to be 4 and negative 3. So we have, so we'll do the Australian. So when a is equal to 1, like I said, you could just stop right there, right? You could just be like y plus 4, y minus 3. If you want to do the Australian method, right, you'd have the 1 and the 1 and then the 1. Factor by grouping is just a little slower because you already have the answers. Plus 4y minus 3y minus 12, y plus 4, negative 3y plus 4, y minus 3, y plus 4. So whenever your a is equal to 1, you can just put your factors there, and it's really quick. Alright, we're going to have 2 you tries, so I want you to pause the video and try because factoring is so important. It doesn't go away like almost ever. You want to be really quick at it. 5d squared minus 18d plus 9. P squared plus 12p plus 36. Alright, so pause the video, try these 2, and then when you come back, I'm going to do them. Alright, so here we go. So we need to multiply to 45, add to negative 18. So I'm thinking 9 and 5. That doesn't work. 3 and 15, that works. So negative 3 and negative 15. So those multiply to positive 45 because the negative times the negative is positive, but they add to negative 18. So let's do 5d, 5d, 5, and then negative 3, negative 15. 5d minus 3 is already simplified. There's no greatest common factor here. I can pull out a 5. And those 2 cancel out. 5d minus 3, d minus 3. And then I'm going to multiply it out to check. So 5d times d is 5d squared minus 15d minus 3d plus 9. 5d squared minus 18d plus 9. So I know that I did it right. Alright, and then here I'll do factoring by grouping. So they need to multiply to 36, add to 12. It's going to be 6 and 6. So I have p squared plus 6p plus 6p plus 36. P plus 6 plus 6p plus 6. P plus 6, p plus 6. Right? And I didn't even need to do all this. I could have just gone straight from here to here because a is equal to 1. But it should work either way. So that's always what I want to show you, is that it'll work. Okay, so that is it. You can decide which method you like. We have the Australian method, we have guess and check, we have factoring by grouping, and you really want to find a method that works for you because factoring is super, super important.